All right, so we are talking 4-4, page 192, and we're talking congruent figures. Now, previously in the year, we've already talked about what it means to be congruent. Right, congruent means equal, but we specifically only talked about congruent segments and congruent angles, and now we're talking about congruent figures. So just a triangle or a rectangle or whatever. So just making the shape a little different, a little bigger, rather than just a segment or an angle. Same idea though, right? The definition that I would use is the second sentence here. That's the one that makes more sense. Okay, it's a little clearer. Congruent figures have the same size and same shape. That's what congruent figures is. Okay, so same size, same shape. Now, the first sentence that you see there relates it back to what we're going to do today. And what it says, two geometric figures are congruent figures if and only if, by conditional, right? If and only if there is a rigid motion or a composition of rigid motions that maps one to the other. What that's telling us are our rigid motions are the three transformations we've already talked about: translation, reflection, rotation. And it's saying any two congruent figures that you have that have the same size, same shape, you can get from one to the other by doing some combination of those three transformations. Right? If I want to get from here to here, it might be as simple as just a reflection. And I get it. Right? And they match up and everything's the same size and everything. If I want to go from here to here, well, then I would rotate it and then translate it. And I could get there. Okay, so this is just saying it is possible to go from one congruent figure to another by using those transformations. Okay. Yeah.
Shape on the far left is not like congruent.
It doesn't look like it. I think it's part of the book being curved. Right, but I think it is. Yeah, it doesn't look like it though. You're right. You're right. It's just the angle that we're at. The ones on the right definitely are not, right? Different sizes, shapes, types of triangles, right? Those are not. So a couple things that we're going to see here with it. We're going to see one where it's just, here are a bunch of figures on a coordinate plane. Identify which ones are congruent, right? Same size, same shape. So just tell the person next to you which ones are congruent out of these. All right, raise your hand. Give me one pair of congruent figures here. Cool. There you go. Yes, I J. Those are congruent, same size, same shape. Levi.
CBA congruent to QPRN.
Good. Yep, QPNR. Good. Fixed it. Can't jump across when you name it. So QPNR. Good. So the squares are, of course. We have one more, Kenzie. There you go. Those two. And then this one doesn't have any match. It's just left out. All right. So it's part of it now. The other thing that we're going to look at in terms of this is this term congruence transformation. And in congruence transformation, we've been doing congruence transformations. We just didn't use this word, right? It's just another name for either one rigid motion or a combination of that. So when we went into those composite ones where we did more than one transformation together, that really was a congruence transformation because it keeps the same size, same shape, right? Because the pre-image image are congruent. So rigid motion, congruence transformation, same exact thing, just another word for it. We're going to go kind of backwards on it today. All right, before they gave us the ordered pairs, they gave us the pre-image. They said, do this transformation, do this transformation. Where do we end up? Today, what they're going to do is they're going to give you both the pre-image and the image, and they're going to say what transformations occurred. And we're going to have to come up with what type of translation it was, how many in what direction. Where did we reflect it? How much did we rotate it? That sort of stuff. Okay, so that's what we're looking at today. let me give you the wording of the problem first, and then I'll show you the picture, because the wording is very important. It says congruence transformation that maps ABCD to EFGH. This is important because it tells us this is our pre-image and this is our image. Because it doesn't have primes, right? So we can't tell that way. We have to look at the wording of the sentence. So we're starting here, we're ending here. Okay, the other thing that it does for us is we have to be careful that our letters match up. So when we do this transformation and we come up with what transformation is occurring, we need A to end up where E is located. We need B to end up where F is located. And that's going to be important. Okay, let me show you an example here before I show you the one out of the book. Let's say I have these two squares. Pretend they're actually squares. Okay, but if I have these two squares, what transformation is occurring? Could be a reflection over the Y. What else could it be? Could be a translation, right? Could just be split over. It could be a rotation of 270 degrees. That would get me there, okay? Which is where the letters come in. So if I call this A, B, C, D, and then this is E, F, G, H, like this, we should be able now to look and say, all right, A needs to end up where E is, B needs to end up where F is, and know exactly which of those three is actually happening. So which type of transformation is this now? First,
A translation.
this would be that translation. Because we're just sliding it over, right? If instead we had E over here and F over here, this is G, this is H, well, now it's that reflection, right? So looking at the letters is what's going to determine, did I do it correctly? Yeah.
What about the 270?
The 270, if I did that, let's see, if I did that, C would match up with G, so G would be there, A would be out here, B is going to end up, where's that going to be? Out here, or whatever matched up with it, right? E and F, and then this would be H. So it would look even different, even more different than the other. Right? So it all depends on where those letters are located. Okay. All right. So I'm going to write this just so that we have it. So we remember which letters have to match up. And then let's look at the picture. Okay, so this is what we're looking at. I want you to talk to the person next to you. What transformations, and there's going to have to be more than one, will get you from here to here, making sure that the letters match up. Yeah.
And then you do a translation. Because it's a dating translation, they would not match up.
All right, so I will tell you that there are multiple ways that we can get there. There's not just one answer here. Okay? So what is one way that we could get from the blue to the green? Jenna? Okay, so if I translate it forward down, that's going to put me here. And then a reflection over the y-axis is going to flip it over and put it right there. Good. That's one way. How else do we get there? Aiden?
Reflection over the x-axis and then the translation.
Okay, so a reflection over the x. If we do that, that's going to give me A here, B here, C here, D here. And then if we translate it, we got to be careful because that's going to put A here, B here, and that's not going to match up, right? A is not going to match up with G. B doesn't match up with H. So this is one where it looks like the shape works, but the letters don't. So we got to be careful on that. Okay, that one's not going to work there.
Wait, so we have to match the A with like
Yeah, it's gotta be based on the way it's listed. The first letter's gotta match up with the first letter, the B's gotta match up with the F, C with the G, D with the H. Okay? Levi?
Don't know if this is gonna work.
Okay.
Well, underneath.
180-degree rotation is gonna put me here. Okay, which is fine, we can be there. Right? Then what?
You just turn it around.
Just turn it around. We gotta have mirror reflection.
Over the Y.
The y-axis is gonna put me over here.
X-axis.
X-axis is gonna put me up here.
That's what.
And then you.
Y equals X is gonna turn it like that. That's not gonna be it.
Negative.
Negative.
That's gonna end up here.
I have it.
Well,
The x-axis and then you do the y-axis.
no, because what's that gonna do? That's gonna take me over the X and over the Y. It's gonna be right back where I was.
Actually, you do a reflection of the X.
And then you
Hey,
go against over the.
here's what we gotta do.
X.
A's gotta become E, right?
Yeah.
B's gotta become F.
Yeah.
D's gotta go up. That's
Over the Y.
Oh, -2.
gotta reflect over that. Got it. So close. So we would have to flip it right there, right?
I wonder
Right,
what.
actually works.
Yeah, I wonder what happens.
Wait, so we just flip it, that's all?
If you did the 180 rotation and then reflect over that y is equal to -2 line, that would get us there. Okay? Hey, the other way that nobody really mentioned here, reflect over the y first, reflect over the y first, and then translate it down.
Okay, that's the same thing as the other one.
Same thing as the other one, just different order. Right?
I wonder what Mr. Krause.
It's in my head.
Yeah, so let's try one more, real quick, one more, and then we got a couple theorems we gotta talk about.
I'm not gonna.
Or you can do.
Okay, real. Again, we are going from blue to green this time. Oh, what do you got? All right, let's see.
The Y, you, look in the Y, and then you translate over.
So if I did that, okay, if I did that on there, right, it's not gonna line up, right? I'm gonna be off on that, right? Hey, and sometimes, guys, this is gonna be easier for some people than others. Because some people have that ability right away to visualize things and know exactly where it's gonna be, and some people struggle with that, and that's completely fine. If you're gonna be one that struggles with it, then sketch it out, right? Sketch it out and draw it, and let's see, let's make sure. Okay, Levi?
You could reflect over the x-axis.
Okay.
Move to the right side.
So reflect over the X, translate it to the right 5, that would work. Or we can translate it to the 5 to the right and then reflect it, we would end there, okay? All right. Any questions about those, Kenzie?
Is there any way I can like do a vertical like thing or something? A vertical trim?
What do you mean?
I don't know, cause you know how when they're like, they're like vertical angles, and so is there a way, like,
Like here to here?
yeah. Is there a way I can do that or something, or
It would be rotating at 180,
no?
and rotating at 180 would be close to being right, but I think again, we would end up off a little bit. and We'd have to reflect it somehow. Yeah. It's gonna be easier to translate and reflect, for this for sure. All right, hey, last 2 things we gotta talk about here. They are gonna take a little bit of time, and we spent some time, extra time going over the quiz and everything, so yeah, we're taking a little longer than usual here today. So these look confusing. Okay, I'll tell you that. If you look at the pictures in the book, they look confusing. And maybe they are, but there's only one certain type of question they're gonna ask. And so as long as we understand the one question they're gonna ask, we're gonna be fine.
Yeah.
Let me explain what's happening here first. Okay, we're talking about reflecting twice. Both of these theorems are talking about reflecting something twice over two different lines. This one, we're reflecting over parallel lines. We're reflecting over parallel lines, and if we do that, we reflect here, we reflect here. The end result is it looks just like a translation. If I reflect over parallel lines, it's going to end up looking like a translation. Okay, so that is what our theorem is telling us, is that if we reflect over parallel lines, it's going to end up looking like a translation. The relationship, what we need to know in terms of this problem is the relationship between this distance, okay, the distance between my two lines, which they call D, and this distance, which is from A to A double prime. We need to know the relationship between those two things. And if we look at it, because these are reflections, these two segments are going to be congruent. These two segments are going to be congruent because it's just reflections, right? So if you look, here is going to be half as long as here. So we're just doubling whatever this number is. So if they tell you that this is 50, this is 100, right? If they tell you this is 300, what is this?
150.
150. So you just need to know which one they gave you and which one they're asking. Okay? That's all we have to do with that here. Okay? The other one is not parallel lines anymore. It's intersecting lines. Okay? So it's intersecting lines. So it's not the same thing. I know this looks even more confusing now. But if I'm reflecting here over K, and then I'm reflecting over M, if these lines are intersecting that I'm reflecting over, it now looks like a rotation. Okay, it looks like a rotation now. So if you have intersecting lines, it's going to look like a rotation. Okay, parallel lines look like a translation. Intersecting lines look like a rotation. Because
Why does the AB get to be connected to like the bottom?
because they're just looking at the very end, the relationship here and here. They don't care about the middle. Yeah.
Oh.
So this is going to be the same sort of thing as the last one. Only instead of distance, they're talking about angle measurement. So they're talking about this angle right here. And then the angle forms when you connect your pre-image, that point, and your image. And it's double. It's the same thing, right? So if this is 60 degrees, this is 120. Right? So whatever this big angle is connecting A and A double prime, if I cut that in half, that's going to give me the angle of my lines of reflection. So it's the same type of problem that they're going to ask. It's either we double the number given or we take the number given and cut it in half. It's just a matter of which one are they asking for. Okay? And that's just going to take maybe sketching it out, maybe just concentrating on it visually. All right, any questions on those? That was pretty quick going through those two lessons or two theorems. Okay, so if you need extra on it as you're going through the homework, let me know and I'll help explain it a little bit more. Okay, you got 5 things copied down for tomorrow. Otherwise, we're good. Okay. Bye, guys. I'm gone.
You guys are coming over.